Good evening, everyone. We are starting this session, which will be about continuing from what we have left yesterday. So, yesterday we were building a payment service from scratch, and today we will be refining the payment service. I have loaded my project in a few minutes or seconds. It should show me the code which we wrote yesterday. We are building a complete e-commerce application. So just I'm waiting for the code to get loaded. Okay. So I go to my package structure and we were working on the payment service here. So we implemented interceptor based logging yesterday. Today we'll be continuing from there. So we have this payment service. In the payment service, we have a README file. Let me preview this. In the README file, we have the details about the service which we created. We created this README file using GitHub Copilot. So here, this is a RESTful application. We use CDI, context and dependency injection. We used RESTful web services and interceptors. Let me expand this as well. Context and dependency injection. So this is what we did. Then we have the features here. Features are, we have a RESTful web service, we have a payment validation and payment processing. We have refund processing capability, we have CDI components, we have logging interceptor, we have a open liberty server. Then we have this folder structure where we have the project. We have multi-layer REST service where we have an entity package, then we have a resource package, service package, and interceptor package. And then we have some configuration files. We have here endpoints for REST clients. We have so yeah, here we have described the architecture or layers. So we started with so we have various layers. We have the resource, we have service. We would also need to document about repository. Correct. Data access layer for interacting with the database. Then we have the service layer, definitely. So I'll name this third point. Then we have entities. Entities definitely are there. We can make it as you need first your entity, then you need a service. Service has the business logic. For the entity, you need a repository. So I'm just updating this documentation. Then we have a resource where you have the RESTful services, and then you have you need a service. And then finally a REST resource which will expose the endpoint. And then we implemented interceptors as well. Perfect. Great. So this is the description about all the layers I've updated. So here you have different packages, Java packages, entity, resource, service, interceptor. Great. So this is about the configuration. We right now haven't used any microservice, microprofile feature. We remove that. That looks good. Then we have Docker will do later once we have our application running. I will explain that there will be lots of concepts that we have to cover. I'll cover Docker and Kubernetes as well. So maybe just for time being, I will say Kubernetes as well. We can put optional for deployment. Great. And then we can deploy it in some cloud platform as well. So which we will use either Google Cloud for cloud deployment, or AWS or Azure. So we will kind of look into various options to deploy. Then we have here some commands for building and executing this. And then we have the details about the endpoints. Okay, so this is the request response format which we were expecting. So some documentation about what kind of positive calls and negative use cases are there, how the validation works, and what are the response request format, what happens when payment is valid, what happens when payment is invalid. All these are documented here. We'll move this going forward into Open API documentation. So then we'll remove it from here. But for the time being, we can put this in this README file. So the problem with this is that, okay, whenever you update the code, you have to update the README file or documentation which is associated with the code which you are writing. So we'll learn more about how to deal with this later. So here there are some validation rules which are documented, and this is the business logic basically. And then we have the technical components. Maybe we should add a description about each of them, like core platform for building enterprise application. Then we have MicroProfile, which provides API for building microservices. We have Open Liberty lightweight application server. So that is fine. Then we have Lombok. Lombok reduces boilerplate code, and that's fine. For Java data classes. And then we have JUnit testing framework. And then we have Mockito. Mockito is a framework for creating unit tests. So right now we haven't used JUnit for integration test. We used JUnit for unit test, and we used curl. We ran some test scripts which were bash scripts, shell scripts, and these were calling curl commands. So these were the integration test which we had so far. We'll see about JUnit based integration tasks also later. Great. So now we have described each of these components. Testing the APIs, what are the ways to test the APIs is also documented. Basically, the test script and how to run it is documented, and what are the various test cases here, these are documented. Fine. So then there are some additional test cases. Then we have a logging interceptor, which is we created an annotation which is called logged, and based on the annotation we will be writing logs when there is a call made to any method in our payment service. So as you see here, without interceptor, we have to write a lot of code for logging at multiple places. But yes, with the interceptor, we have very clean logic, and we just have to put this logged annotation. And whenever there is an entry and exit of a method, automatically that will be logged. Also, we are logging exceptions. So the benefits are clean code, consistency. We have all the methods which will follow the same format of logging. We have maintainability, changing log behavior in one place, which is the interceptor. will apply the changes everywhere. Automatic metrics, we can track the execution time for which of the methods. We have automatic exception logging, and we don't repeat our logging logic. Everything is in a centralized place. So this is what we have. We have various methods. So we have logging at method entry, we have logging at method exit, we have logging at execution time and exception. So these are the logs which will be generated. So we have some details about the interceptor binding here, how the interceptor was implemented. We defined that the interceptor should be retained in the runtime because logging happens in the runtime. We defined the target, which was the class and the method. So the target is at the type level and the method level. And this is the interface where we have around invoke. We have, this is also called as aspect oriented programming, where you inject some code without attaching the code, or without writing the code in between lines, but you can inject from outside and modify the behavior of any existing code without touching that code. So this is called aspect oriented programming. Here we have log method calls. We have CDI configuration, and here we are registering the configuration to scan for the interceptor and then apply the interceptors. And then some best practices. We have documented that, okay, we should not log the credit card numbers. We should use PCI compliant payment gateways. This is a best practice payment card interface. We should implement proper encryption for sensitive data. We should use HTTPS for all payment related communication, and we implement proper authentication and authorization. We should store payment data securely according to PCI DSS standards, implement rate limiting to report abuse, and add proper sanitization and validation. Okay, then what are the next steps? So next steps are, one which is very important is we will be implementing idempotency for payment request. So let me start doing that. Basically, it will update the REST methods to the put method, and so here I have asked the Copilot to suggest how I can make the payment request idempotent. And idempotency means that if you have payment button and you pay, and if it's taking more time, sometimes our tendency is to click multiple times the pay button, but it should not charge our credit card multiple times. So it's first examining our source code. It's looking into the resource, service, and our entity, which is payment details. It has come up with a proposal. So it's suggesting to use a idempotency key. So it's a header based idempotency using an idempotency key, which is what is being used. Now see here, put can help you to do the idempotency in browser based interaction, but if we have service to service interactions, you would need an idempotency key. So you have a record, concurrent hash map could be used for this purpose, and we can have auto expiry of old records, so we don't so we can create an idempotency service, and it can prevent duplicate processing. Okay, so let me check. Can we implement put method for payment to ensure idempotency? Let's see. I have asked about what is put method instead of so this is a better idea, it's suggesting, because it's more restful as per HTTP specification, and put is idempotent. So it has started. So you see here in the Copilot, I have following settings. I have delegate session, you have background and cloud. So here if you use local, which is what I am continuing in, and there is something called background. In background, we delegate the task to background agent, which is running locally on our machine. Agent iterates via chat and works asynchronously in Git worktree to implement changes, and these are isolated from your main workspace. So that's you can run it as a background task, or you can delegate it to GitHub Copilot coding agent. Iterates via chat and works asynchronously in the cloud to implement changes and pull requests as needed. Great. So this is a nice thing about Copilot, that it has three modes. One is local, which is what you are seeing. Other one is background, which is where you won't see what it is working on. And the third one is the cloud, where it will be running in the GitHub cloud, and not as a background service on the local machine, nor it is running as a task on the cloud. So there's a plenty of changes which has been done to implement the idempotency. Let's see. So you have a payment process. We have a payment ID. Okay. So a client will provide a unique payment ID. Whenever you have a payment which is getting processed, the ID will be cached for 24 hours. If the same payment ID is used again, the cached result will be returned without reprocessing the payment. If the payment ID is used with different payment details, a conflict status is returned. Okay, this is good. Prevent duplicate charges. Multiple identical requests will only result in a single payment. Clients can safely retry failed requests without risk of double charging. Use put method, which is inherited idempotent per HTTP specification. Clients generate and manage their own idempotency key. Okay, so there has been changes which have been made. Let's look into this. So what has been done is just looking into, we have the payment entity. We have one more entity which is idempotent record. This record has the payment ID, request details, success, response message, timestamp, and what's the expiry. Then we have payment details. There we have the payment ID, which is unique identifier for idempotency support. So this has been added. Then you have a resource, payment resource, where you have idempotency service, which is also injected in this. And what does this idempotency service do? Process payment idempotent. It will check if the payment ID is not null. Payment ID is, it will set the payment ID and it will get the existing record. If record is present, then it will give the status. Otherwise, if it is not matched, it will return for different payment details. And then if and this is for processing the payment for the first time. If it's not found, and then it will create a response. So this is how we implemented idempotency service. Okay, so looks good, simple, and in-memory caching is also there. We could use Redis as well going forward. And there is a test script also, which is for testing idempotency. We have a record for idempotency. We have an idempotency service, which is getting the existing record and store record. So basically, it stores it in the cache. It fetches the details and it takes care of clearing records. So this could be called by a schedule task. Okay, so let's run this. Now it's making the test script executable. So we'll keep this as of now. Later we may remove if we feel it is very complicated, but it's a good learning that how to implement an idempotency for payment. Okay, it's compiling it. Let me ask, do we really need a idempotency record or just an ID or just put method is sufficient for ensuring idempotency in payment service? So here, this is different approaches which could be used. So when we don't store the ID, it cannot prevent duplicate processing. So here are the benefits, like you have conflict detection, which is also required. So yeah, we just asked Copilot to implement idempotency, but it has provided an approach which is as per the industry standard, which also ensures conflict detection, response consistency, because when you retry, you should get the consistent response. We should also this also implemented audit trail. So what about let's choose show both approaches with the comments explaining trade-offs. So that way we will be sharing so yeah, it's now simplifying the first version where we have just the idempotency implemented, and then we'll have a full version which will show okay, so it's creating another class which is a simple class, service simple. It's adding a new endpoint for simple approach, and it will have a different resource. So at the same time, let me run another background agent, which will, I'll say, create a blog explaining step by step how to implement idempotency in RESTful web service. For example, payment service. First, implement using simple approach, discuss the shortcomings, and then improvise to full implementation with conflict detection. Format this blog post as .adoc file. So I have created another background request. So this is a background agent. So it's asking whether to have the uncommitted changes. So I would say yes, because these agents are working in parallel. So I would say copy changes, uncommitted changes, and should these changes be included new? Yes. There's a background agent, and then there is another one which is running here. So I'm running the background agent for the first time, so not sure how actually it's managed. So this is what has been edited. Looks good. And then there will be a session list. So session list is this is implemented. Remaining microservices. So here we have the two service implemented. One is the simple, other one is full implementation. And they have been used with comments, appropriate comments. Now let me look into the session list. So let me ask so we could have used this instead of this switcher, we can use at CLI at cloud how to view the session list. So that we can see the progress of our agent which is working on. Okay, so here is the Copilot icon. Then you have the tasks. And then, no, it's looking, so I'm in the chat view. Okay, Copilot chat view. This is the Copilot chat view. And look for sessions or background tasks. So we have to look into the background tasks. Okay, so we could type here show sessions or view backgrounds task. So here Copilot, uh, here Copilot, and then view background So what's the status of my background task? Let's see if it can return something, because I'm not able to find out my background task as per the documentation. Perfect. So let's get it done with the help of current agent. So this will be good for now, as we have the block, we can remove the simple implementation of idempotency from the source code. So this is what I would like to do next. So this is how you can steer a current session. So this is a great feature. Like when Copilot agent is working, you can provide directions and further improve the way it is working. So it's starting with a simple discussing shortcomings, then follow the full implementation and use code examples from payment service we just implemented. So this is there's a blog post file which has been created. So it's preparing that right now. And then we'll review it, and then in the meantime it should be deleting the implementation from our existing code. So this is a great way uh, to document all our learnings, and at the same time keeping our code clean and as per the best practices. So next we'll learn about implementing audit trail for payment service and see how it's implemented. And going forward, we will implement it using telemetry, distributed telemetry, if it can help. We could have asked it to create an article basically about idempotency. I said blog post. Hope there should not be much difference, but yes. Let's see. It is written 29 lines. I can't see what's currently in progress. Maybe once all the right lines have been written, then it will be able to update it. Yeah, now okay, by the time it's writing the blog, we can run this service. So first thing I'll go is I'll go to our code folder, code folder. Then we have our chapter. This is chapter 3. And then we have a service called payment service. There seems to be some Java related configuration issue. Let me select the language model. This seems to be really slow. I'm not sure why. I'm not getting the expected results. This is slow. It's taking a lot of time. Usually it should not take that much time. There should be some performance issue in the background services. So now it says it has created a post or blog about it. But it's analyzing something, not sure what. I'll wait here. So basically, yeah, we could have done this task later, and this could be assigned to a cloud agent. That would have been a better option, because then in the background it could have done all the analysis and would have written the results, so we did not have to wait it. So now you understood the difference between all kinds of agents. One is the foreground agent, background agents, and the cloud agent. I believe if you're working on something and you want to in parallel do something else with the agent, then you need background agent or cloud agent. The only difference between the background agent and cloud agent is that background agent will run on your local machine. Cloud agent will run on your GitHub cloud. I would prefer running a cloud agent, because if you run background agent, then your current system's performance could become slow, which is now the case in my IDE, as there are some background tasks running. So I am seeing little bit slow performance in my terminal, and this is a good enough VM. It has, I believe, the configuration of this VM is 64 GB RAM. I think, yeah, it's like 32 GB RAM and 4 CPUs. Still with background agents, it's running slow. And this is Codespace, GitHub Codespace. So it has these 4 tasks, and it has taken my inputs. So this is the to-dos and these are the background tasks. Okay, now let's proceed and we go to the terminal. We are into our repo. Let me say compile this. Okay, it's still slow, so let's not wait further. I will take a break. In the meantime, it should return back. Let me see now. Now the response is still not good. The other problem I see is when you will stop a background agent. Oh, sorry. When you will stop your code space, your background agent will also stop. But with cloud agent, you don't have to be in active session in code space. So I think very handy. The cloud agent is very handy because you can close, you can sleep, you can have coffee, and once you come back, you will see the task getting completed. But in case of the foreground agent, you have to be there. You have to approve various command execution, and then same is the case with the background agent also. It do things in the background, and then you have to have the session running all throughout when it's working. It's in development, so it will improve. I'm seeing good improvement, rapid improvement in GitHub in last few months. I've been using it since one year now, almost like 1 year. So let's have patience and then wait for these tasks to get completed. and it looks like it's stuck. So let me do one thing rather than just waiting. We'll restore to a checkpoint, and the checkpoint would be creating I'll restore till we implemented this particular. So this is also very useful thing. You can have a checkpoint and then you can restore it to some previous conversation state. So this is what I'm doing. I'll remove all tasks. And now hopefully it should restore it fast. I will do this with the cloud agent because now I have understood these concepts. These are on my mind. So we have the implementation of idempotency. Then we will look into implementing transaction logging and audit trails. Now let me in the meantime also understand what is difference between transaction logging and audit trails. So this is another concept. So here is the differences between transaction logging. Its purpose is for data integrity, crash recovery, performance monitoring. Audit trail is a regulatory compliance, accountability, and security monitoring. So what happens? Technical database level changes. Who did what and why? So this is what user level actions and modifications. So transaction logging is technical. Audit trail is business oriented. Persistence often temporary, used for recovery. And this is long-term retention, sometimes immutable, cannot be altered. Audience is system administrators, developers, and in audit trail, it is auditors, security officers, compliance officers. So these are the difference between audit trails and transaction logging. Okay, now I see there is a idempotency block also created as part of the background. Server pay now on website. So this is So here, these are nice details. Okay. So this looks good now. They have written a blog post. Did so here it has all the shortcomings. Okay, finally our task is completed. This is great. I'll say keep for time being. Great. So now we have this implementation. Let me compile this code. Just see if it's building. Tests are run. Everything is successful. Now let's run this in dev mode. So now it should be running. Now, by the time it's running, we can create another terminal. And in this terminal, we can go to run the test script. So chapter 3 and payment. Now, if I look into the test scripts, we have here test api.sh. So here we can see that, okay, there are various requests which will be made on this service. So first request is validate payment details. So here, this is the request body. Let me hit enter to see. Yeah, this is processed. So it's okay. Then our second request would be to validate invalid payment. So in the first case, we got this response, valid true. In the second case, we are still getting payment details are valid. Let's look into it. It should not be, or is it? Expiry date format is invalid, right? So it should not read. Card number is invalid. Okay. So there were lots of invalid requests. Now here it's giving validate invalid payment, 0 amount. Empty cardholder name. Process valid payment is fine. Process refund. Fine. So this is we'll say fix, or let's test idempotency. So with put, so there is a first payment request. Press enter. So we have got the second payment request. So here we may just ask, can close this. We will open the testidempotency.sh. Why are we getting while executing this test script? So this is the testing is completed. So this service is working well, but let's clean it up to implement. So let me go to the test script. is here say review this test script and remove unnecessary or incorrect tests from this. So this should complete our implementation for idempotency. Okay, it's reviewing test.api. So it's reviewing against the resource file, and it is understanding that okay, what all validations are there. If so, it has found the issues and it is suggesting what should be removed. So then unnecessary tests are removed. So for example, card number length validation is not there, expiry format validation is not there, CVV length validation is not there, all that. So all the incomplete tests and unnecessary tests are not there. Next, we'll ask to implement transaction logging and audit trails in our payment service. And also we have to fix the test idempotency. Test script, because it's giving this error, which is parse error invalid numerical literal. We've got rid of 100 lines of code. Let's see what has been changed. Right, modified one test cases and removed multiple test cases. Okay, so this is now fine. Just let's execute this one time again. And in the meantime, I'll also ask to review the other test case. Review test idempotency for why this is giving this error. And let me execute this. So here valid payment details Then there is validate invalid payment. This false, returning false, which is correct. It's returning true. This is also correct. Why this payment detail is invalid? Because card name is not there. So payment details are invalid. Then we have another, which is amount is 0. Then payment is processed successfully, process valid payment. So you have validate payment and process valid payments. And here again, cardholder name is not there. So the payment processing should fail. And then here a valid refund. Processed, and then there's another valid refund. There is invalid refund, which is 0 amount. And negative refund is also rejected. So this is how our testing is complete. Now it has reviewed idempotency test cases as well. So let's see what has been changed. So some response parsing was there, which was failing. So it kind of fixed that. Let me test this. Right, so it's now looking good. You have first payment request with a UUID, and this has been successfully processed. So here the same payment ID details have been returned. So cash was there. It was no reprocessing was done, and this is a conflict test case, and this completes our idempotency tests. Now let's look into our terminal for our logging. So here our interceptor is enabled. So if we go, okay, so let's ask this also about why we are not seeing logs. Why are we not seeing logs from interceptor? Because this is enabled and it will only be invoked in the priority part of the chain. So it's checking the implementation. Because on each of the method entry, method exit, and exception, it should generate log messages. And the logging configuration should also be enabled for the files, so which is missing, looks like. if it fixes this configuration, then we will rerun the test cases and see if the logs are generated. Logs will include tracing the methods, their performance logging, and also exception logging. So it has found the issue, and the logging configuration was missing, so it has been added in the file server.xml, which is within main liberty server.xml. So console level logging equal to info. This has been added. Update this, and then let's run again the tests. So we run one method and let's see what happens. Logs, are they generated? So you see here the entering method log has been there. So for validate payment, and it's entering here validate payment details. It's exiting this message, exiting these methods. So now the logging has been enabled properly, and we got these logs as expected. When I will make further calls, it will create more logs. So you see here more logs are getting added. This way logging is enabled properly. So now there is an invalid refund. So refund payment. So every time we are calling a method, it is tracing it or logging it. And it's a pretty much uniform formatting, and without adding log statement. So we are not polluting our code with log statements, still getting very good amount of logging. So now let me commit all these changes so far. Let me add all that to staged changes, and then let me create a commit message. And let me commit this. And we should sync this change as well, because I have committed it to the local repository. It should also be synced with the remote repository. The other option is I could have chosen commit and push instead. This is a very nice interface in VS Code for committing the changes to GitHub. Now, next part is let's implement audit trail. So I want to implement transaction logging and audit trails in payment service for right. So it is creating an audit entity, a service, and it will integrate into payment service. So I could have asked to first suggest an approach and then proceed. So it's the way it's doing is it has created a new record, which is payment audit record, which has the audit ID, payment ID, operation type, timestamp, status. Then there is a masked card number, the card holder name, and there is a transaction amount and the detailed message about the operation, who's initiated the operation, and the client identifier, duration in milliseconds, cache response, metadata, and different operation types are there, different operation status are there, success, failed, validation error, conflict, system error. So this is a detailed implementation of audit trail, and it's also implementing masking of credit card number, because that's a sensitive information. If the entire credit card number is logged or added in the audit trail, then it will have problems. And then there is a audit service. This is a Restful service. It has various parameters. Okay. So it will add all the parameters and it will create an audit record and it will log it. And this is an audit logger. So this is going to be logged. So here is the audit ID, which is again a UUID. And now let me see where is the audit logger class. So this is audit logger, where it is defined. Probably in the payment service. Let's see what changes they have done. Is still working. I'm not seeing the, yeah, it's working on the payment service. So that's why it's not opening right now. But yes, here in the payment service, I see that, okay, there has been changes. They have added the timestamps. So basically, this is all about adding a business logic and logging. So there's no new concept which we are learning here about microservices. It's all about adding more logs and logging at the business level. Okay, there is a service resource class which has also been generated. So what all REST methods are there? So basically, it will get all the audit records. It will get for a particular payment ID the audit records. So there are various operation type filter which are available for audit records. So it's generating a README file as well. And it is also adding here for payment audit. Logging level is getting enabled. Okay, there is a test script also created for audit logging. It's updating the README file. In the README file, we have the details about audit trail logging. So I'm coming down. So here, transaction logging and audit trail. Transaction audit logging is already there. We have various APIs for auditing. Let me also ask, do we already have the transaction logging implemented because we have very thorough logging implementation, or do we have to do anything further? So card numbers are masked, CVVs are never logged, records are immutable. There's a separate logger for easy filtering and all operations are covered. And there are various endpoints which are available to get the records. And the audit record definitely will be stored in the database. I think there should be a mapping with the database table. No, it's not there. So then that's a problem because audit storage, because then only we'll be able to retrieve all of them. If it's not stored in database or some persistent storage, you won't be able to retrieve it. So if we see in this get audit stats, it's getting from the memory. Okay. So it's getting from the memory. So by the time the server is running, the records are available. Once you restart the server, records will not be available. They will be flushed off. Okay, it's trying to compile this. We can skip this. So we don't want the records to be persistent now, but yes, this is an important point that they should be persistent in database. So right now they are currently stored in memory only. What kind of database is best for, is most suitable for storing audit trails? Because relational database are not that much great for storing. I will use here ask rather than agent. And then I'll also ask, do we already have transaction? Okay. Relational database, it's recommended. But the time series database is best for high volume because you can have the time-based queries. So this is what I was suggesting, that if there are high volume transaction, we can use time series database. Document database, MongoDB is also good. But then you will have to create complex queries and eventual consistency could be an issue. So here, less flexible for complex queries, time series database. But yeah, we may not need complex queries. Some filtering options would be great. So yeah, I would suggest 1 and 2. Now let me ask about the transaction logging. But you may have fraud detection, performance monitoring, then business analytics, operational monitoring, tracing, etc. These all other are required. So we are getting into the deep inside logging and audits because right now we won't be implementing it because here this we are trying to implement using default frameworks, but we will use open telemetry or distributed tracing for it. going forward. There we will implement it in a more thorough way. So right now this solution is decent enough, good enough. Let's look into the other catalog service. This is the product service with logged. So here let's remove. Let me close this, because our other implementation of catalog service is very thorough. Here we have used qualifiers for accessing in-memory or repository, different types of repositories, which could be in-memory and a JPA-based repository. So these are the two options which we can kind of change by using qualifiers. This we have discussed in our session yesterday. So we can remove this service, which is about implementing the interceptors, because now we have the interceptors implemented in our payment service. So we have the logging implemented, we have the idempotency implemented in payment service, we have the audit trails implemented in payment service. So that will complete the implementation of the payment service. So now next things which we would like to do is we'll see what else we can do. Payment audit resource, this is the commit message which is generated. Let me implement payment audit trail system. So it has details about all updates which have been done on payment service. These are various changes. We can stage all the changes. And we can commit and push these changes. I'll close all the open files. So now let's look into the next chapter project, which is chapter 4. So chapter 3, we had this chapter which was about, I'll show you the content. So we had the chapter 3 which was on the core profile. And in the core profile, we covered various aspects of REST services and CDI, including interceptors, qualifiers, and validations, JSON binding, JSON parsing. So these all topics were covered. And in the next chapter, we have MicroProfile Open API. So let's look into the example for chapter 4, which is MicroProfile Open API. Now I have updated this chapter as well. Okay, let's also stop the server because this project is complete. And in the next, we have okay, again the source code, which is having a catalog service and MP e-commerce store service. So catalog service will be based on the implementation where we have in-memory, JPA, all these concepts implemented. And then we have another service, which is the catalog, which is MP e-commerce store service, where we have demonstrated webhooks, asynchronous product resources, webhooks, and we have here product event. So webhooks implementation is there in this product service, and with open API documentation. So if you look into the product resource, we have this well documented. So here you have the schema tag, which defines that there's a tag. So this is open API documentation. So let me update this chapter because here we have introduced more concepts around open API. Open API is which we call Swagger as well. And I will be doing a separate session on Swagger where we will be covering each and every aspects of open API or Swagger UI, how to document your microservices in a manner that is very convenient and is along with your code, so you don't have this problem of mismatch between the documentation and the code. Your documentation will be generated from your RESTful resources code, which is this APIs, as we have these as annotations on your code. It is easier to update for developers, and it will be auto-generated with every build. So you will never get it out of sync. So these features we'll discuss in the next session. So for today, I'll close this session and we will look into Open API and many other concepts in the coming sessions. So thank you. Any questions if you have, you can post in the comments. for